There's a machine in China that cleans highways at over 100 kilometers per hour. It looks like something between a truck and a spacecraft. It moves in the fast lane of a 6-lane expressway, surrounded by normal traffic, and it vacuums debris off the road surface at full highway speed. No lane closures. No cones. No flashing arrow boards diverting traffic. No crew in high-visibility vests standing in a live lane hoping nobody drifts into them. The road stays open. The traffic keeps flowing. And the highway gets cleaned. If you've ever sat in a 40-minute delay because a maintenance crew was sweeping a half-mile stretch of freeway at 15 miles per hour, you already understand why this machine exists. And if you live in the United States, you've probably never seen anything like it. Because nothing like it operates on American highways. That's not an insult. It's a fact of infrastructure priorities. And to understand why China built this and America didn't, you need to understand the scale of the problem China is trying to solve. China operates the largest expressway network on Earth. As of recent reporting, the system spans over 180,000 kilometers of high-speed roads. To put that in perspective, the United States Interstate Highway System, the largest in the Western world, covers roughly 80,000 kilometers. China's network is more than double that, and it's still growing. New expressway sections are being added every year as the country continues expanding its transportation infrastructure to connect cities, industrial zones, and rural regions across a landmass roughly the same size as the United States, but with more than 4 times the population. Every kilometer of that network needs to be maintained. Debris accumulates from tire wear, vehicle parts, cargo spillage, weather damage, and general road use. On a quiet rural highway, that debris can sit for weeks without causing problems. On a high-speed expressway carrying tens of thousands of vehicles per day at 120 kilometers per hour, a loose piece of metal, a chunk of tire rubber, or a scattering of gravel can cause a blowout, a swerve, or a multi-vehicle collision in seconds. Highway cleanliness is not cosmetic. It's a safety function. And at China's scale, keeping 180,000 kilometers of expressway clean using traditional methods is functionally impossible. Traditional highway cleaning in most countries works the same way it has for decades. A maintenance crew arrives at the section that needs cleaning. They set up lane closures, cones, barriers, flashing arrow boards, sometimes a full lane or shoulder shutdown. Traffic is diverted or slowed. The sweeper vehicle enters the closed section, operating at low speed, typically between 10 and 30 kilometers per hour. It sweeps or vacuums the debris. The crew removes the lane closure. Traffic resumes. The process works. It's safe for the workers when properly managed, but it is brutally slow, massively disruptive, and in some cases, deadly. Highway maintenance workers are among the most at-risk laborers in the transportation industry. In the United States alone, according to the Federal Highway Administration, a highway worker is killed in a work zone accident roughly every other week. Drivers distracted by phones, fatigued from long hauls, or simply not paying attention drift into work zones at highway speed. The cones and arrow boards don't stop a car. They're visual signals that depend entirely on the driver noticing them and reacting in time. When a driver doesn't react, the workers in the zone pay the price. And then there's the traffic cost. Lane closures on busy expressways don't just slow down the cars in a closed lane. They cascade. A single lane closure on a high-volume highway during peak hours can create a traffic queue that stretches for kilometers. Commuters lose time. Freight slows down. Fuel is wasted in stop-and-go congestion. Emergency vehicles get stuck. The economic cost of highway lane closures has been studied extensively, and the numbers are staggering. In the United States, traffic congestion costs the economy hundreds of billions of dollars annually. Not all of that is from maintenance closures, but a meaningful share of it is. China looked at this equation, the safety risk, the traffic disruption, the economic cost, the impossible scale of 180,000 kilometers, and decided the traditional approach didn't work at their volume. The answer they came up with was not to make the lane closure faster. It was to eliminate the lane closure entirely. The high-speed road sweeper is designed to operate as part of normal traffic. It enters the expressway from an on-ramp, merges into the flow, accelerates to highway speed, and begins cleaning while traveling at the same velocity as the vehicles around it. There is no lane closure. There are no cones. The machine occupies a single lane the same way any truck would. The difference is that while it drives, it is vacuuming debris from the road surface at highway speed. The engineering required to make that work is more complex than it sounds. At low speed, sweeping a road is straightforward. Brushes push debris toward a vacuum intake. The vacuum sucks it into a hopper. At highway speed, everything changes. Air resistance becomes a major factor. Debris that sits still on the road surface at rest gets caught in the aerodynamic turbulence created by the vehicle itself. The vacuum system has to generate enough suction to overcome not just the weight of the debris, but the airflow that's trying to scatter it. The brushes have to make contact with the road surface while the vehicle is moving at over 100 kilometers per hour without bouncing, skipping, or damaging the pavement. The collection system has to capture material ranging from fine dust to chunks of tire rubber and metal fragments without clogging or losing suction over long operating distances. The machines that do this are purpose-built. They are not modified conventional sweepers. They are engineered from the ground up for high-speed operation. The chassis is designed for highway stability at speed. The vacuum system is integrated into the vehicle's undercarriage with aerodynamic shrouding to manage airflow around the collection zone. The brush assemblies are mounted on suspension systems that maintain consistent contact pressure with the road surface regardless of speed or pavement irregularities. The debris hopper is sealed and pressurized to prevent collected material from being ejected back onto the road by the vehicle's own slipstream. And the entire system is built to operate for extended distances without stopping, because the point is to clean continuously while driving, not to stop and start. Some versions of these machines reported in Chinese state media and industry coverage can clean multiple lanes in a single pass by using offset vacuum heads that extend beyond the vehicle's own width. Others operate in coordinated pairs or groups, covering adjacent lanes simultaneously. The result is that a section of expressway that would traditionally require a 2-hour lane closure can be cleaned in a single pass at traffic speed with zero disruption. And this is where the American comparison becomes relevant. Not because American engineers couldn't build a machine like this. They absolutely could. The United States has some of the best vehicle engineering, robotics, and infrastructure technology in the world. The reason nothing like this operates on American highways is not a capability gap. It's a priority gap. Highway maintenance in the United States is managed by state-level departments of transportation, each with its own budget, procurement process, and equipment standards. Innovation in highway maintenance equipment tends to be incremental: better brushes, better trucks, slightly faster deployment of lane closures. The fundamental model of close the lane then clean hasn't changed in decades. There's no federal mandate to develop high-speed cleaning systems. There's no centralized procurement program that could fund the development of a purpose-built highway sweeper that operates at traffic speed. And the fragmented state-by-state approach means that even if one state developed something innovative, adopting it nationwide would take years of separate procurement cycles. China's system works differently. Infrastructure investment is centralized. When the national government identifies a need, in this case, maintaining 180,000 kilometers of expressway without crippling the traffic flow, it can direct funding, commission development, and deploy solutions at a pace and scale that decentralized systems struggle to match. The high-speed sweeper didn't emerge because Chinese engineers are smarter. It emerged because the system they operate in allowed the problem to be addressed as a national infrastructure priority rather than a state-by-state incremental upgrade. That's not a value judgment about which system is better. Both approaches have strengths and weaknesses. Centralized systems can deploy faster, but can also waste resources on poorly chosen priorities. Decentralized systems are more responsive to local needs, but can be painfully slow to adopt innovations that require coordination across jurisdictions. The point is that the high-speed sweeper exists because the conditions for its development existed in China and did not exist in the same way in the United States. But let's be honest about the limitations. Because this machine is impressive, but it is not magic. First, the high-speed sweeper handles surface debris, loose materials sitting on the pavement, dust, gravel, tire fragments, small objects. It does not repair potholes. It does not fill cracks. It does not resurface worn pavement. It does not fix structural damage. Highway maintenance involves dozens of different tasks, and cleaning is only one of them. The sweeper solves the debris problem. It does not solve the road deterioration problem. Second, operating a large vacuum and brush system at highway speed generates significant noise and vibration. The machines are loud. In urban expressway sections where highways pass through residential areas, noise restrictions may limit when and where these machines can operate. A highway sweeper running at 120 kilometers per hour at 3 in the morning through a residential corridor is not a zero-impact solution. Third, safety at highway speed is a double-edged sword. The machine eliminates the risk to maintenance workers standing in a closed lane. That's a genuine and significant safety improvement. But it introduces a different risk. A large specialized vehicle operating complex mechanical systems at highway speed in live traffic. If a brush assembly fails, if debris is ejected from the collection system, if the vehicle has a mechanical issue at 120 kilometers per hour surrounded by passenger cars, the consequences could be severe. The risk profile is different, not eliminated. Fourth, the economics work at China's scale. When you have 180,000 kilometers of expressway to maintain and hundreds of millions of vehicles using them daily, the investment in purpose-built high-speed maintenance equipment makes financial sense. When you have a smaller network, lower traffic density, or a maintenance model that already works well enough, the cost of developing and deploying an entirely new class of equipment may not justify the benefits. American highways have real maintenance problems, but the economic case for a fleet of high-speed sweepers is harder to make when the network is less than half the size and the governance structure spreads the cost across 50 separate state budgets. And fifth, the footage and claims about these machines come primarily from Chinese state media and industry promotional material. Independent third-party testing and long-term performance data, the kind that Western infrastructure agencies typically require before adopting new equipment, is limited. That doesn't mean the machines don't work. It means the information available is largely from the manufacturer and the government that commissioned them. For a channel committed to factual accuracy, that's worth noting. Despite all of that, the core innovation is real and the engineering is sound. A vehicle that can clean a highway at traffic speed without lane closures is a genuinely useful piece of infrastructure technology. It reduces traffic disruption. It reduces worker exposure to live traffic. It reduces the economic cost of maintenance-related congestion. And it addresses a scale problem that traditional methods cannot solve efficiently. The question is not whether the technology works. It's whether other countries will adopt it. And right now, the answer seems to be not yet. American highway agencies are watching. European road authorities are aware of the concept. But adoption requires testing, certification, regulatory approval, operator training, fleet procurement, and integration into existing maintenance programs. That process takes years and systems designed around caution and incremental change. In the meantime, China's expressways are being cleaned at highway speed by machines that most of the world hasn't seen yet. The debris gets collected. The traffic keeps flowing. The lane stays open. And somewhere in the United States, a line of cars is sitting behind a row of orange cones, waiting for a sweeper doing 15 miles per hour to finish a stretch of highway that a Chinese machine would have cleaned in a single pass without anyone noticing. The most advanced road sweeper in the world doesn't look like the future. It looks like a truck. It drives in traffic. It doesn't have a viral video doing a backflip. Nobody is writing headlines about it. But it solves a problem that costs billions of dollars and dozens of lives every year. And right now, only one country is using it. That's not because the technology is a secret. It's because most countries haven't decided it's a priority yet. China did. And the highway kept moving.